Have you ever wondered what happens if you try to calculate the factorial of 1/2? We know that 3 factorial is 3 times 2 times 1, which equals 6, but the logic of repeated multiplication breaks down completely when we step between the integers. To solve this, we cannot rely on simple arithmetic. We must look to calculus to find a continuous function that connects these discrete points. We are looking for a smooth curve that passes through every factorial value. The solution lies in a specific definite integral discovered by Lenhart Euler. Watch as we construct this integral from scratch. We start with the exponential decay function, e to the power of -t. If we take the integral of this from 0 to infinity, the area is exactly 1. Now imagine we introduce a new term to the mix. We multiply the exponential by t raised to the power of z minus 1. This creates the gamma function. As we visualize the graph of the integrand, notice the competition between the two parts. The t term tries to pull the graph up towards infinity, while the exponential term crushes it down towards 0. This creates a bump or a pulse with a finite area. To prove this area represents a factorial, we use integration by parts. We differentiate the term t to the power of z minus 1, and we integrate the term e to the power of -t. See how the power rule brings the exponent down to the front. The exponent z minus 1 becomes a multiplier, and the new power becomes z minus 2. When we evaluate the limits, the boundary terms vanish to 0. We are left with a recursive relationship where the value of the integral for z is equal to z minus 1 multiplied by the integral for z minus 1. This mirrors the fundamental property of factorials, where 5 factorial is 5 times 4 factorial. However, there is a distinct shift. Because of how the integral is set up, gamma of n actually equals n minus 1 factorial. For example, gamma of 5 is equal to 4 factorial. This integral definition allows us to plug in fractions and even complex numbers, creating a beautiful continuous landscape that generalizes the factorial concept for the entire complex plane. If you enjoyed this explanation, hit subscribe and check out our other math videos.